This video is on solving equations. This first example is solve the equation if possible. So the first step, I would say, is to distribute this 8 to both terms in the parentheses. So 8 times x is 8x, and then 8 times 2 is positive 16. Then distribute the negative 3 through to both terms in that parentheses. So negative 3 times 2x is negative 6x. And then negative 3 times 1 is negative 3. Then on the right side of the equal sign is multiply both terms in the parentheses by 2. So 2x times 10. Now let's do some combining of like terms. So I have a like term with 8x minus 6x is 2x. And then I have a like term with 16 and 3. 16 minus 3 is positive 13. And then I still have that 2x plus 10 on the right. Now I want to combine like terms again, so I want to get my x's together. So let's go ahead and subtract 2x from both sides. So 2x minus 2x. Uh-oh, what happens is I'm left with just 13 equaling 10. If my variable cancels out, this means I do not have a solution. It's not possible to solve this equation for x. Here's the next example. Now we have some fractions going on. So my recommendation is to multiply all terms by the LCD to get rid of any of those fractions that are there. So our first two fractions are 15 over x and 6 over x. So what is the LCD here? Well, the LCD is an x here. It also has an x here. So the LCD is x. So I'm going to multiply all terms, all four terms by x. So I'm going to just go ahead and rewrite the original equation again. And now multiply all those terms by x. Let's make sure those have fractions there. So multiply all terms by the LCD. So I have that x here, an x here, an x here, and an x here. Now the nice thing about multiplying by all terms by the LCD is your fractions will cancel out. This x and this x will cancel out to be 1s. This x and this x will cancel out to be 1s. So now we're left with 15 minus, and then 4 times x is 4x, equals 6 plus 3x. Now we solve it just like we do with other linear equations. We want to combine like terms. So let's get our x's together. So I'm going to add 4x to both sides. So I'm left with on the left is just the 15 because the 4x and the negative 4x cancel. And then 6 plus, and now these become 7x. 3x plus 4x is 7x. Now we need to get the constants together, so I'm going to subtract 6 from both sides. And we're left with 15 minus 6 is 9. The 6's will cancel out on the right. And then we're left with 7x. Last step is divide both sides by 7. Divide by 7, divide by 7. 7's will cancel, left with x, and then 9 sevenths. I like to write my variable first, then my answer. So x equals 9 sevenths. Here's another example of an equation that has a fraction in it. It has two fractions. It has x over 3 and 3x over 4. So we want to ask ourselves, what is the LCD of this problem? So what is the LCD of 3 and 4? How can I get those two to cancel out? Well, the LCD is going to be 12. So I'm going to multiply all terms by 12. So let's rewrite the original equation again. So x over 3 plus 3x over 4 equals 2. And now we multiply all three fractions by 12. By 12, by 12, by 12. Now the fun begins where we can start to cancel. So we can reduce this first fraction by 3. So both of these can divide by 3. So we're left with 4 here and 1 there. These two fractions can divide by 4. So we're left with 3 here and 1. Nothing can cancel on the right side of the equation. Now we can go ahead and do some multiplying. So 4x over 1 is just 4x plus 3x times 3 is 9x over 1 is just still 9x. And then 2 times 12 is 24. Now let's combine like terms on the left. 4x plus 9x is 13x equals 24. Now divide both sides by 13. 24 13ths is my answer. Solve this equation if possible. This is a little more challenging because the LCD is a little bit harder to see. I want to get rid of those denominators, so the LCD is going to be two pieces. It's going to be this, x minus 1, and 3x plus 1. So I need to multiply all three fractions by that LCD. So I'm just going to rewrite this equation again. So 4 over x minus 1, I'm going to leave some space, plus 6 over 3x plus 1, leave some space, and then 15 over 3x plus 1. Now we multiply all three fractions by the LCD. So we have x minus 1 times 3x plus 1, x minus 1, 3x plus 1, x minus 1, 3x plus 1. Now let's see what cancels. What cancels in the first fraction is the x minus 1 and the x minus 1. In the next fraction, we have the 3x plus 1 and the 3x plus 1 cancel. In the last fraction on the right side of the equation, we have the 3x plus 1 and the 3x plus 1 cancel. Now let's clean up what we're left with. What we're left with in the first fraction is the 4 and the 3x plus 1. So 4 and then 3x plus 1. In the next piece, we're left with plus 6 x minus 1, plus 6 x minus 1. In the last piece, we have 15 and then x minus 1. Now we solve like any other linear equation. We need to distribute the 4, the 6, and the 15 through. So distribute the 4. So 4 times 3x is 12x. 4 times 1 is 4. Distribute the 6 through. So 6 times x is 6x. 6 times negative 1 is negative 6. And then 15, distribute through. You get 15x minus 15. Combine some like terms. 12x and 6x become 18x. 4 and negative 6 become negative 2. And then that right side is still as it is. Now we need to combine like terms. So I'm going to add a 2 to both sides. So these 2's will cancel. We're left with 18x on the left. On the right, we have 15x. And then negative 15 plus 2 is negative 13. Now we need to get the x's together. So I'm going to go ahead and subtract 15x from both sides. The 15x's will cancel on the right. So we're left with negative 13 on the right. On the left, 18x minus 15x is 3x. Last step is divide both sides by 3. We'll save this one for warm-up.